So I'm also going to be talking about first-party data, but I'm going to be focusing on the importance of the infrastructure that you have internally to manage that data and the implications on managing that data well for things like KYC and fraud detection. First, quickly to myself, my name's Stephen Renwick. I'm co-founder and CEO of Tilores. Been living in Germany for 11 years now. Brexit-proofed myself, so I'm now British and German, which is handy. Tilores we founded at the end of 21. It's actually a spin-out company. I was previously the chief product officer in a German consumer credit bureau. So my background is really in data. I'm not from a banking or payments, payments background. Yeah, so in the credit bureau, you can imagine we're dealing with large volumes of data on every single person in the country, and managing that data is extremely difficult, actually making sense of that data, as I'll show. So if you hear people talking about data management, you'll often hear them make reference to this problem of data silos. You've got data stored in different databases. You've maybe a large company and you've got data within different subsidiaries, and nobody really knows how this data is all related together. So it's a very common problem that people just talk about these data silos. How can we solve these data silos? You'll hear people talk about technologies like data warehouses. Nowadays, people are talking about data lakes and data lake houses. But the reality is that most of the time, people are living with a data swamp. And what I mean by that is they've got large volumes of duplicate data. They've got records that should be linked together, but can't be linked together because they don't know how. The data is of questionable provenance. Nobody knows how long it's been there. Nobody knows if they're really legally allowed to use this data. This is such a common problem. It affects something like 90% of companies can't get true value from their data because most of it is relatively unusable. So looking at this in the kind of the fraud prevention space, why is this important? So this is all about first-party data. We see in fraud cases that about 14% of fraud cases are committed by repeat offenders. The actual number is probably much higher, but that's what's kind of known. And what we do know is that those repeat offenders actually cause a disproportionate amount of the actual or value of fraud. So if you could catch these guys when they're coming back, that would be ideal, but that depends on how good your data is. So this just shows a kind of a typical example of the sort of data you might see when you're looking at an e-commerce fraud case. So on the right-hand side, you've got a historic fraud attempt by Scrooge McDuck, who has a particular date of birth and lives at a particular address or is given a particular address in Berlin for delivery of some products. He's got his email address there, but he was confirmed as fraudulent sometime in the past year. Later this year, you have somebody new sign up to your platform. You don't really know if they're attempting fraud, but they've just signed up to your platform. Completely different name, completely different date of birth, different address, but you can see there's some similarity in their email address. Now, that's actually quite common in fraud attacks, that the fraudsters are using algorithms, they're using bots to create accounts as they go along, and you can actually do similarity matching between the email addresses to say, okay, there's a high similarity between these two email addresses. It's possible they're the same person. Now, if you know those two addresses in Berlin, you'll know that they're actually within about 100 meters from each other. So you can use those two bits of information to say, okay, A is probably related to B. So far, so easy. The problem is that real fraud data is much more complicated than this. You may have account B is related to account B, account A is related to account B, but then it's related to account C, D, E, F, and these, what we would call identity graphs, can become very, very large, very, very complex to actually use. And the challenge with that is if you're using machine learning for fraud detection, then you have to make a decision very, very quickly on this data. In e-commerce, you want to make your decision within a few hundred milliseconds, but it actually takes so long to retrieve this data that the algorithm itself is only able to run on the first few parts of the data. So you end up with your algorithms only running on 5% or 5 or 10% of the available data. And if the actual important part, which would flag this really as a fraudulent transaction, is at the end of this identity graph, then you're not actually able to properly predict that this is fraudulent. So to give you a kind of an example from a customer of ours, we work with a relatively well-known European buy now, pay later company providing their data infrastructure for fraud detection. When we did a test with them in one of the new markets they'd entered, they'd been working there for 6 months or so. They gave us a sample of a few tens of millions of euros worth of their orders, represented by or made by 14,000 accounts that they had in their system. Once we ran the entity resolution or the identity resolution on this data, we were able to say you don't actually have 14,000 customers, you've got 11,000 customers here, which is quite a sort of common use case. You think you've got all these customers, actually you've got much less. And what we're using here is basically the first party data to tell you how many customers you really have. And we were looking at this from the fraud detection point of view. As I said, there were 1,700 entities, as we would call them, where there was more than one customer ID linked in. We would sometimes find entities with up to 189 records linked to them. Many of these connections were kind of non-obvious. It's the sort of thing that if you were an analyst spending 10 minutes looking at every single new account coming in, you could maybe make that association, but doing this in real time as the e-commerce is going on is very, very difficult. And we were able to make the links between previously blacklisted records and incoming new customers. This was in the Spanish market, and we found clusters of fraud that were happening in these small Spanish villages, where it was very unlikely that this random small Spanish village was suddenly making 300,000 euros worth of Apple orders all in the same day by coincidence. And the sort of matching we were using was based on time, credit card data, and addresses. This is how the data kind of looks. We refer to these in the kind of the data science world as identity graphs. You might think of them as golden customer records. On the right-hand side, you've got a kind of normal customer. Each dot represents an order that they've made. These orders have been deduplicated and linked to the one person. There's no problem with that. As far as we're concerned, from a data point of view, it looks fine. On the left is a suspicious customer. You've got their 6 orders, I think. 2 of them are deduplicated to one person. The rest of them are, as far as the retailer is concerned, separate people. We're able to link them together and say there is some kind of relationship between these 5 people. Whether or not that means it's fraud, it's not for us to say. It's for the retailer to run their machine learning model on it to say whether or not they think it's fraudulent, or to send that data to an external fraud detection tool. So yeah, the most extreme case that we found in this data set was the 182 records that were linked into 10 different entities. So that's 182 orders made to theoretically 10 different people that we managed to link together with a total order value of 136,000 euros from one person, and all delivered to 2 different villages, all using the first-party data, which was, a lot of it was based on the credit card data, but also some other information like the addresses, etc. And here just kind of showing you the geolocation of that on the map. And yeah, in this case, we were partly working with historic data, so we were able to do a blinded test. And of all the fraud cases that they'd already identified, we were able to identify 100% of them just by doing the identity linking. And then on top of that, we discovered a significant extra amount of fraud that they didn't know about yet, because the transactions had only recently happened. We were able to say, okay, all these new transactions are linked to these previous fraudulent transactions, therefore there's a high chance you're never going to end up getting paid for these. It turned out to be true, and we calculated from this data set that we were able to protect 1.8% of their revenue, or put another way, for each genuine order that they had, we would be able to save them around about 9 euros by preventing the losses. Just another point on the technology side of things. This is all about databases and data infrastructure. The technology that we built for the credit bureau that we spun out, it's based on what's called serverless technology. It's a very hands-off technology that you don't need engineers running on it. It basically runs on its own. So for this client, we're able to also save them a significant amount of money on engineering costs, and that was estimated at 250,000 euros per year. So What happens if you don't do this? So here's a case that we have relatively recently. If you've probably seen this in the press. Block is the company that was formerly known as Square, founded by Jack Dorsey, the co-founder of Twitter. And Square, initially, everyone knew them for the little thing you plugged into your iPhone to do credit card payments in shops. More recently, they've become well known for their Cash app, which allows you to do very simple mobile phone to mobile phone transactions. Now, what happened recently is a research-driven fund called Hindenburg Research published a 2-year analysis of Block in which they accused Block of having very lax KYC and identity resolution, or internal KYC and identity resolution, and many other things. And Hindenburg shorted the stock of Block, and as soon as this research was published, Block's share price, as you can see in the top left, dropped, I think it was about 15% almost immediately. So whether or not it's true or not, remains to be seen, but some would say there's no smoke without fire, and people are questioning whether this is the American Wirecard. But what you can see in the two kind of graphics is one of the problems that Hindenburg said they uncovered is that they Block knew about these networks of people that were related, but they did nothing about it. So they would have accounts that had previously been blacklisted, and then they would have somebody else sign up with a new account with either the same phone number or the same email address or some kind of relationship between them, and they just wouldn't do anything about it. They would allow it still to happen. What's strange in this case is that Block seems to know about it, because those diagrams apparently come from Block's own internal CRM system. From our experience, the challenge with doing this sort of identity graph building is not building the graph itself. That's something you can do kind of slowly. The challenge is doing it in real time as accounts are created. That's where we kind of specialize, and for all we know, maybe their problem was that they couldn't do this analysis as the accounts were created, so they only realized later. Nevertheless, these accounts were still created, they were still active, and you can read the report yourself if you have the time, it's rather long, but the joke was that something like 70% of the accounts had other accounts linked to them that made them look suspicious, and yeah, it was relatively easy within this company to make fake identities like Donald Trump, and within 2 days get a prepaid card delivered to you. So this is why using first-party data for identity resolution is important. I showed the fraud case. This is more the kind of the KYC case. Banks are being encouraged to move away from the one-off KYC to the perpetual KYC, and this is really why it's important. So, like I said, we refer to these kind of colloquially as golden customer records, and as Tilores, our proposition to everyone is that you should be using the maximum amount of data that you can to make decisions, whether it's credit risk decisions, fraud prevention, or KYC. And real-time golden customer records are the data set you need to actually make these decisions correctly and accurately. And that's me, I believe. Yep.
So thank you, Stephen. One quick question.